Alright guys, in this video we're going to be covering 3B.3. Our mastery learning objective is I can solve quadratic equations involving imaginary numbers by taking the square root or completing the square. So first thing is, well, which method do you use and what does it need to look like? So to use the square root, you're typically either going to have an x squared already, plus or minus some constants or other numbers equal to 0. The other time that you can take the square root is if you have like a quantity that's being squared. So like for example, x plus or minus some value that's being squared. And then there's also another k value equal to 0. So if it looks like any of those two, you should solve by taking the square root. If you are going to complete the square, it should typically be in standard form that says x squared plus or minus bx plus or minus c, which is all equal to 0. And again, you probably are going to have that a value in front. So sometimes it might be there, sometimes it might not. So if it's in that form where you have 3 terms, then you solve by completing the square. So this video is just being able to determine which method to use and then solve using that method. So even just looking at the first two, looking at number 1, I have the quantity of x minus 6 squared plus 8 equals 2. Which method would I use? Probably the square root. And then looking at number 2, I have 3 of those terms. I see really the only thing that's being squared is the x. It looks like it's in standard form. So for this one, I would do completing the square. Alright, yes, we still are going to solve these. I just kind of wanted to show you 2 examples right at the front just to be able to show you how I can tell the difference. And again, you could use whatever method, but obviously you want to pick the easier one. Alright, so quantity of x minus 6 squared plus 8 equals 2. Steps for completing the square. I need to bring over that constant. So I do the opposite, the inverse, which is subtract 8. I'm going to be left with x minus 6, quantity squared, is going to equal negative 6. Again, that becomes a 0, and then 2 minus 8 is a negative 6. I have to take the square root. So x minus 6 is going to equal a plus or minus. I'm going to separate my negative, so 6 times negative 1. X minus 6 equals plus or minus. I'm going to remove that I out, and there is no square root of 6. So square root ends up at the end. I still have to isolate my variable, so therefore I have to add 6 on each side. That becomes a 0, and I'm left with x equals 6 plus or minus I square root of 6. Those are not like terms. There's not much I can do, so that is my answer. So again, it's nothing new. It's just being able to determine which method to use and when, and then same as B1 and B2. So looking at number 2, I already said that I'm going to be using completing the square, so I'm going to bring over that constant because that is the first step when I complete the square. I have x squared minus 10x plus some constant minus 50 plus that same constant of the left side. So I have to complete the square. I'm going to draw my Punnett square box over here. I find my b value, which is negative 10x. Remember, keep that sign. Cut it in half, so I'm going to divide by 2, and I'm left with negative 5x. When I do my Punnett square box, I will have my x squared here, and I already said that this is going to be negative 5x, negative 5x. So therefore, the outsides of my Punnett square box, x times a negative 5, x times a negative 5. And then my constant then, the actual value that I use to complete the square is going to be negative 5 times negative 5, which is a positive 25. That is the number that I add on the line. Again, nothing new, the same as what we were just doing in that last video. Alright, next step is to write the perfect square trinomial. So I'm going to write x minus 5 quantity squared equals negative 50 plus 25 is a negative 25. If you were lost on where I got that x minus 5 from, right, this is exactly what I just had on each side of my Punnett square box. Now it kind of typically turns into a problem like completing or like taking the square root because I want to get that x by itself. So I am going to take the square root of both sides. This is going to be x minus 5 equals Square root of 25. I will have that plus minus sign. So square root of 25 times a negative 1. X minus 5 equals plus or minus. There is a square root of 25. That is 5. Square root of negative 1 is I. I want to add 5 over to the other side. So my final answer here, I'll make it a different color. Alright, bring this on over here. This is going to be x equals 5 plus or minus 5i. If you want to take the GCF out, you can. You can see that both values can be divided by a 5, so our GCF here would be a 5. If you'd like to practice that, you can remove a 5 from each, which would give me 1 plus or minus I. Again, if you do not take out that GCF, it is okay. You can still leave that as your answer. You do not have to remove the GCF. Next example is example number 3. I have x squared plus 7. So I don't have 3 terms, so I probably would not use completing the square here. I would do square root. All right, so getting that square root, I want to get the whatever's being squared by itself. So this is x squared. So I want to do the inverse operation. So I'm going to subtract 7 on each side to get my x squared by itself. It's going to equal negative 7. I'm going to take the square root of both sides. So x is going to equal a plus or minus 7 times negative 1. I'm going to bring down my x equals plus or minus. Bring out that I because there is no square root of 7. And that is my final answer. Number 4, x squared plus 2x plus 4. They are 3 terms, so I would do completing the square here. So I'm going to bring that constant over to the other side. X squared plus 2x plus some constant equals negative 4 plus that same constant of the left side. I want to do my Punnett square box. Right, I know I'm going to have that x squared there, but I need to figure out what's on the diagonal, so I find my b term, which is that 2x. I'm always dividing it by 2, which would give me 1x. So therefore, 1x and 1x. That would mean my Punnett square is x plus 1, x plus 1, which would make my constant 1 times 1, which is a positive 1. That 1 is what I add on each of those lines. And my perfect square trinomial ends up being a binomial squared. So x plus 1 squared equals negative 4 plus 1, which is a negative 3. Still have to solve for x, so I take the square root of both sides. X plus 1 equals a plus or minus square root of 3 times a negative 1. X plus 1 equals plus or minus. I'm going to remove that I, bring that out in front of the square root sign. Square root of 3. Still have to get my x by itself, so I will be subtracting 1 on each side. So therefore, my final answer is negative 1 plus or minus I times the square root of 3. Alright, that is our final answer. You can go ahead and work on this activity, 3B.3. And then you should move on then to the AB quiz review. So that's also in your activity packet. You could, after you finish that activity, work on that review, and then you will be taking that AB quiz. All right, good luck.